Hey guys, Doug here with your Week 10 MyStatLab Problem 3 example. In our problem, a market researcher working for a bank wants to know if the distribution of applications by card is the same for the past 3 mailings. She takes a random sample of 200 from each mailing and counts the number applying for silver, gold, and platinum. The reported results appear in the accompanying table. So here's our table: silver card, gold card, platinum card, 3 mailings, and the number of applications. So let's get on with our problem. What are the null and alternative hypotheses? Well, it asks us if they are the same. So that leads us to our null hypothesis that the proportions of customers applying for the 3 types of cards are the same for the 3 different mailings. Which on the other side of that, our alternative hypothesis, the proportions of customers applying for the 3 types of cards are not the same for the 3 different mailings. So there we have it, part A. Part B, what type of test is this? Well, let's look at our 3 types of test. A chi-square goodness of fit test determines whether the distribution of counts in one categorical variable matches the distribution predicted by the model. The second one, a chi-square test of homogeneity, compares the distribution of counts for 2 or more groups on the same categorical variable. And our third one, a chi-square test of independence, determines whether 2 categorical variables are independent. It examines the distribution of counts for one group of individuals classified according to both variables. Well, in this case, we have 3 groups here. So that leads us to the chi-square test of homogeneity. That we have counts of 2 or more groups on the same categorical variable. There we have it right there. So that would be our answer to part B. Now let's move on to some numbers, have some fun. What are the expected numbers for each of the null? What are the expected numbers for each cell if the null hypothesis is true? Well, let's look at that. The formula for that is on page 435 of your text. And we're going to take the row total times the column total and then divide by the grand total or table total, as I like to call it. So for our silver column, we're going to take 200 times 385 and divide it by 600. So let's go ahead. Equals, in parentheses, we're going to take 200 times 385, close our parentheses, divide by our total of 600, and there we have it, 128.333. So all 3 of these numbers will be the same because we're doing row times column. So we can go ahead and place that in there, 128.333 and 128.333. For the gold, again, our formula equals, in parentheses, our row times column, close parentheses, divided by total, enters. So this column is going to be 55.667. And then our third, again, equals, and in parentheses, row times column, close parentheses, divided by our total, and we get 16 there, there, and there. So there we have it. There are our expected numbers for each one of these if our null hypothesis is true, and that's telling us that the customers applying for the 3 types of cards are the same for all 3 different mailings. So that gives us those exact totals that way. So that's part C. Let's move on to part D. What does part D want to know? It wants us to find the chi-square statistic. All right, for that you can look at the formula on page 424 in your textbook, where we're going to take the sum of all of these cells, where we're going to take the observed minus the expected squared divided by the expected. We should be able to do this one time and copy and paste. And I put our table down here so we can have a look at it. So let's start with silver and we'll try it and see what happens here. So we're going to say equals, and in parentheses, observed, which was the 132. Let's get that straight here. So we're going to say equals the observed 132 minus the expected in parentheses, and then we're going to square that. So where is my symbol here? Squared, and then we're going to divide by the expected, which was 128 again here, and let's hit enter. There we have it. For this one, our total is 0.1048. Now we should be able to copy and paste this all the way around. So let's go copy. Let's try to paste it here first. And then we'll do it here also. And there we have it. There are all of our chi-square statistic totals for each column and in each row. Now to find our chi-square, we have to sum all of these numbers in our table. So let's go over here, and I'm going to say equals. Start typing sum. There it is there. And then in parentheses, I'm going to highlight the whole area there. So all of our data is there. Hit enter. And there we have it. There's our chi-square statistic at 8.2893. That wasn't too bad, was it? Once we got one formula and copy and pasted the rest of them, that made it pretty easy. So now we can move on to part E. Part E asks us how many degrees of freedom does the chi-square statistic have? Well, now we know we need to take our column minus 1 times our row minus 1. So 3 minus 1 is 2. 3 minus 1 again is 2. 2 times 2 is 4. So we're going to have 4 degrees of freedom here. That's all we need to do there. Moving on. Find the critical value at alpha at 0.05. Now, I found this neat site here that I'm going to use, and I'm also going to post this link along with this video. Makes it very easy to come up with this critical value. I liked it, and all we need to know are our degrees of freedom, which we have at 4. Let's minimize this, and here's the site here. Now we need to make sure we're clicking on critical value because that's what we want. This chi-square calculator. Our degrees of freedom are 4. Let's click here, and there we have it. There's our critical value, 9.4877. That's all we need to know. So let's go back here. We're going to put 9.4877, and there we have it. There's our chi-square value, which we use our table for, and our critical value, which we use this neat little calculator that I found online. So that leads us to the last part of our problem, part G. Is the chi-square statistic, is it greater than the critical value? If it is, then we reject the null hypothesis. Let's look at it. Chi-square is 8.28. Critical value 9.48. So in this case, the critical value is greater than the chi-square. So in that case, we do not reject our null hypothesis. And there you go. That's it. That's our whole problem. We made it easy with Excel and one little neat little site here. Hope you had fun with this, and we'll see you on the next time.